Hey, IQ Kid here to talk about derivatives. So I already did a derivative, or I already did a video about the definition of a derivative, which is right here. So the derivative of f of x with respect to x is the function f prime of x, and is defined as f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So that whole thing right there can be made a lot easier. So I know that's like really complicated, and you have to have a decent amount of calculus or pre-cal and math basically to do it. So you have to know about limits to do it. So I'm going to boil down this whole thing right here, so that way you can do it with just algebra. So this function right here, f of x is equal to ax to the n. If you take the derivative, that's the standard function. If you take the derivative of that, you get the exponent is brought down, multiplied by the exponent, and then you subtract 1 from the exponent. So that's all that's happening. So this is going down, and then this, you're losing 1. So minus 1. So something to take note of, if you take the derivative of a constant, so let's say it was like 5x plus 1, and you were to take the derivative, this constant right there, the 1, that would go to 0. Now this 5, since that's attached with the x to the x, that would not go to 0. So yeah, that would not equal 0. Okay, so let's go ahead and do an example. So in this example, let's find the derivative of this function. So this is a right here. If you look at this is your constant out front, this is your variable, and this is your exponent. So in the first example, we're looking at the constant out front, the variable, and the exponent. So let's go ahead and write the shortcut. So f prime of x is equal to n times a x to the n minus 1. So let's identify the pieces to plug in. So a is equal to 3, and n is equal to 2. Alright, and then now let's go ahead and plug it in. So f prime of x is equal to, let's see here, n, so 2, times a, 3x, to the n minus 1, so 2 minus 1. So let's go ahead and simplify that to get f prime of x is equal to 6x. And that's your final answer. Now, wasn't that a heck of a lot easier than the really long, cumbersome limit definition right here? That's how much easier derivatives can be with this simple formula. Alright, let's go ahead and look at another example. In this next example, we're going to have it be a little bit more complicated. So this time we're taking the derivative, but there's more than just one component. So let's write the shortcut again for step 1. So f prime of x is equal to n times a x to the n minus 1. So when you take the derivative, you're just taking the derivative of each part if it's addition and subtraction. So this part you're taking the derivative of, this part you're taking the derivative of, this part you're taking the derivative of. So let's identify the pieces. So a1, so the first constant out front, is equal to 3. a2, the second constant, is 6. n1 is 2. n2 is 1. So, and then the constant is 27, but that won't matter because that'll go to 0. So let's plug it in. So f prime of x is equal to n, so n1, 2, times 3, since it's a x, to the n is 2, minus 1. So then plus, go ahead and bring that in. And then we're looking at n, so n2 is 1, times a2 is 6, x to the n, n2 is 1, minus 1, and then minus the 27 goes to 0. Okay, so that goes to 0. Okay, so let's go ahead and simplify that. So f prime of x is equal to 6x plus 6. That's your final answer. Okay, and now let's try another example. So in this example, I'm going to make it a little more complicated by introducing variables in the denominator and variables under a radical. So let's simplify to contain or to have exponents instead of that form, the simplified form. So f of x is equal to 3x to the 1/2, since the 1/2 is the same as the radical, plus 2x to the negative 1. So x to the negative 1 is the same as 1 over x. So that 2x to the negative 1 is the same as 2 divided by x. Okay, so step 2 is to write the shortcut. So f prime of x is equal to n times a x to the n minus 1. Okay, let's identify the pieces. So let's see here. A1 is 3. A2 is 2. N1 is 1/2. And N2 is negative 1. Okay, so step 4 is to plug in. So let's take, so f prime of x is equal to n1, so 1/2 times a1 is 3, x to the n1, so 1/2 minus 1, plus n2, negative 1, times a2 is 2, x to the n1 or n2, negative 1 minus 1. So then let's go ahead and simplify that. So f prime of x is equal to 3/2, and then the x is going to be 3/2 x to the negative 1/2, plus negative 1 times 2 to 2x to the negative 2. Okay, so we can simplify that further. So let's do f prime of x is equal to 3/2 x to the negative 1/2 minus 2x to the negative 2. So this is a final answer. Some teachers will want you to leave it with the exponents, and if your teacher wants you to put it back in the form like it originally was, then we can rewrite it, so that's optional. So f prime of x is equal to 3 over 2 radical x, since as you might remember from the beginning of the problem. If the exponent is 1/2 or is any fraction, it means it's going to involve a radical. So 1/2 would be the square root. And then minus 2 over x squared. Since it's x to the -2, that means it's 1 over x squared times 2. So it's 2, so minus 2 over x squared. So this is your final answer. These two right here, those are equivalent. Okay, so that is all I have on making derivatives easier. So thanks for watching. I hope this helped. If you have a question or would like to make a request for the next video, don't hesitate to contact me. You can reach me through the email in the description. So yeah, have a wonderful day, and always strive to make each day better than the last one. Like, comment, subscribe. Until next time, IQ Kid signing off.